This is Lecture 8 for Music Theory Fundamentals. Today we will be discussing the intervals of fourths, fifths, and sixths. We'll start with a quick review about finding the correct quantity of interval on a staff. Then we'll move on to learn about perfect fourths, perfect fifths, and major and minor sixths. Let's get started. In Lecture 7, we learned that a line to a neighboring space, or a space to a neighboring line, is always an interval with the number 2, also called a second. We also learned that a line to a neighboring line, or a space to a neighboring space, has the interval number of 3, also called a third. This is because when we have two of the same pitch, sounding simultaneously, the distance between them is called a unison. We label this interval capital P1. This means perfect unison. As we count each step away from any given pitch, above or below, we add a number for each line, space, line, etc. that we move farther from the given pitch to determine the quantity of that interval. This is a perfect unison. Two pitches sounding simultaneously that are the same pitch, on the same line, the same frequency. They might be played by two different instruments, but they are the same pitch in unison. This is an interval of a perfect unison. When we move one step away, we call this interval a second. Move one step further, and you have the interval of a third. Continuing on to the next space above that line, we have the interval of a fourth. Beyond that, up to the next line, this is the interval of a fifth. And if we continue one more to the space above that line, we have the interval of a sixth. We can calculate this interval as a sixth by starting on the G and counting up line, space, line, space, line, space. G is 1 for our unison. E is 6 for our sixth above G. It is essential to remember that when we count lines and spaces on the staff to determine the quantity of an interval, the line or space of the given note is 1, or unison. When we move to the neighboring line or space, the quantity is 2, a second. If you plan to count line, space, line, etc. to determine quantity, remember this. For a moment, ignore the question of quality, major, minor, etc., and determine the quantity of each interval pictured above. Is it a second, third, fourth, etc.? Let's determine this by counting from the line or space that the lower note is placed. Our first interval has a lower pitch of C. So starting on that C and working our way up to F, we will count 1, 2, 3, 4. This interval is a fourth. The next interval starts on A and we count up 1, 2, 3. This interval is a third. Following that, we start on a G and count up 1, 2, 3, 4, 5, 6. This is an interval of a sixth. The next one should be very familiar. It's just 1, 2 for a second. And finally, starting on C, we move up 1, 2, 3, 4, and 5. This interval has the quantity of a fifth. Now that we've learned how to find the correct quantity of an interval on a staff, it's time to discuss the quality of fourths, fifths, and sixths. We will start with fourths. Lecture 7 showed us that seconds and thirds can be minor or major quality. Fourths, however, are not minor or major. When we discuss the quality of fourths, fifths, unisons, and octaves, one of the words we use is perfect instead of minor or major. There are no major or minor fourths, fifths, unisons, or octaves. You may be wondering why. I'll be honest, if this were a music history course, we'd go over this topic in detail, but because it's music theory, I'm just going to ask you to take my word for it. You can do a Google search if you're curious to know the answer. To construct a perfect fourth, we can use either of the methods we learned in Lecture 7, counting half steps or the key signature method. But the first step, as always, has not changed. Put it on the staff. Let's start with the key signature method. We will construct a perfect fourth above each given pitch. Write the pitch that constructs the quantity of a fourth above each of these pitches. It's a line to a space or a space to a line. You can also think of it as one step wider than a third. So if the space above that first A is a C to make that a third, you'd go one step wider than that, up to the line that's D. Now we will find each of the lower pitches on our circle of fifths and apply the key signature of the lower pitch to the upper pitch. The first lower pitch we see is A, and in the key of A major we have 3 sharps, F, C, and G. The upper pitch is a D. D is not on that list, so D doesn't need a flat or a sharp. This is a perfect fourth, A to D. The next pitch we see is D flat in the bass clef. We find D flat on our circle of fifths. The key signature of D flat major has 5 flats, B, E, A, D, and G. G is one of our flats in the key signature, and we need to add a flat in front of that pitch on the staff. Let's keep going. Treble clef, F sharp. It appears here on our circle of fifths, and it has 1, 2, 3, 4, 5, 6 sharps. Everything's sharp except B. So even with all of those sharps, it's already correct, and we don't need to change anything about the B in order to make this a perfect fourth. Finally, we have F in the bass clef as our lower pitch, and a B above it. In the key of F major, we have 1 flat, and that's B flat. So in order for this to be a perfect fourth, we'll need to add a flat in front of that B. What if the lower pitch doesn't exist as a major key on our circle of fifths? Start with the same letter name that does exist on the circle. We don't have an A sharp major on the circle of fifths, but we do have an A major. In the key of A major, we have 3 sharps, F sharp, C sharp, and G sharp. D is not on that list, so an A to a D is a perfect fourth. However, we don't need to know a perfect fourth above A. We need to know a perfect fourth above A sharp. We can determine this by changing both of these pitches by a chromatic half step. If A is raised to A sharp and D is raised to D sharp, we maintain the same interval of a perfect fourth. So adding that sharp sign in front of D, we find our correct answer. Let's look at the next example. We see a D sharp on the staff, but we don't see a D sharp on our major circle of fifths. We do, however, have D, which has two sharps, F and C. G is not affected by our key signature for D major, so a D to a G is a perfect fourth. If a D to a G is a perfect fourth, then a D sharp up to a G sharp is also a perfect fourth. Moving on, we see an F flat as our lower pitch on the treble clef. We don't have an F flat on our major circle of fifths, but we do have an F. And in the key of F major, there's one flat, B flat. So an F up to a B flat is a perfect fourth. Now we need to adjust both pitches by a chromatic half step. If we move F down to F flat, and we move B flat down to B double flat, we keep the same interval, a perfect fourth. So the correct answer of what is a perfect fourth above F flat is B double flat. The last pitch we see is E sharp. We don't have an E sharp on our major circle of fifths, but we do have an E. And in the key of E major, we have four sharps, F, C, G, and D. A is not on that list, so a perfect fourth above E is A. Now we raise both by a chromatic half step. E can move up to E sharp. A can move up to A sharp. This maintains our interval of a perfect fourth. The correct answer is A sharp. Now let's practice using the key signature method to write a perfect fourth below each of these pitches. Start by placing a note a fourth below each given pitch. That's putting it on the staff. Next, we view the key signature for the lower pitch. E major has four sharps, F, C, G, and D. So a perfect fourth above E is A. Now we need to move our upper pitch down to A flat because that was the given pitch. If A down to E is a perfect fourth, then A flat down to E flat is also a perfect fourth. Next in the bass clef, we were given a D flat, and we wrote an A below it. The key signature for A major is three sharps, F, C, and G. D is not on that list, so A up to D is a perfect fourth. Now we need to adjust both pitches down by a chromatic half step. D moves down to D flat, and A moves down to A flat. This maintains our interval of a perfect fourth. So a perfect fourth below D flat is A flat. Moving on, F sharp in the treble clef will go down a fourth to some kind of C. We love the key of C major. It has no sharps and no flats. So a C up to an F is a perfect fourth. Therefore, if we raise our F to F sharp and our C to C sharp, we maintain that interval of a perfect fourth. A perfect fourth below F sharp is C sharp. Finally, we have a B sharp, which is going to go down a fourth to some kind of F. The key of F major has one flat, B flat. So an F up to a B flat is a perfect fourth. Here's where things get a little bit tricky. We can raise our B flat by a chromatic half step up to B natural and raise our F by a chromatic half step up to F sharp. But we're not there yet. We have to do this one more time in order to find a B sharp on the top. This means our F sharp is raised an additional chromatic half step to F double sharp. So a B sharp down a perfect fourth is F double sharp. This is about as hard as it will get. So if you stuck with me for this process, you're doing great. Now that we've thoroughly covered the construction of perfect fourths above and below various pitches using the key signature method, you might want to take a minute to stop and stretch and rest your brain before we dive into perfect fifths. Go ahead, it's healthy for you. If you're comfortable using the key signature method to construct perfect fourths, then constructing perfect fifths should be relatively quick to learn. It's the same process we just used, with the exception of starting by putting an interval of the quantity of a fifth on the staff. One way to find the fifth above is to count up 1, 2, 3, 4, 5 steps. However, I have a way that I think is a little bit simpler. A fifth is a line to a line or a space to a space, but we skip one in between. I'll show you what I mean. Starting on that G, if we go line, 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 we have a fifth. Or space, starting on the A, space, space, we have a fifth. In my opinion, this is a little bit easier than counting every other line and space to arrive at the correct number. Let's do one example in treble clef and one in bass clef to give us some experience constructing perfect fifths. We start by placing a note on the fifth above each of the given pitches. Then we check our circle of fifths to determine key signature. So in the treble clef, we use space, space, space to find the fifth above, and in the bass clef, we use line, line, line to find the fifth above. Our first interval has an F sharp in the bottom, and we find our F sharp here at the bottom of our circle of fifths. It has 6 sharps, F, C, G, D, A, and E. C sharp is one of the sharps in our key signature. So in order for this to be a perfect fifth, we'll need to add that sharp before the C pitch. Looking at the interval in our bass clef, we see the lower pitch is a B flat. We can find our B flat on the circle of fifths and recognize that B flat major has 2 flats, B flat and E flat. Since a fifth above a B is an F, and F is not one of the flats in our key signature, this is already a perfect fifth, and we don't need to change anything. If we are dealing with pitches that do not exist on our major circle of fifths, we start with a key that does exist and make the required adjustments. For example, our first lower pitch is an E sharp, and there is no E sharp on our major circle of fifths. However, we do have an E. A fifth above E is going to be some kind of B. E major has 4 sharps, F, C, G, and D. B is not one of our sharps, so B natural is a fifth above E natural. Now we'll change them both by the same chromatic half step. E is raised to E sharp, B is raised to B sharp, and we still have our perfect fifth. So we add the sharp in front of the B note. Looking at the next interval with an F flat as the lower pitch, we recognize that there is no F flat on our major circle of fifths, but there is an F. An F to a C is a perfect fifth. Why? Because in the key signature of F major, we have one flat, and that's a B flat. So if an F to a C is a perfect fifth, then an F flat to a C flat is also a perfect fifth. Let's put the flat in front of our C note. When we construct a perfect fifth below using the key signature method, we again calculate with the key signature of the lower pitch. In our first example, our lower pitch is F, and we know that a perfect fifth above F is a C. Now we'll need to move that C down to a C flat, which means we also need to move the F down to an F flat in order to maintain the same interval. A perfect fifth below C flat is F flat. Let's look next at the B sharp, which will go down to some kind of E. In the key signature for E major, we have 4 sharps, F, C, G, and D. That means E to B is a perfect fifth. Now we need to find a perfect fifth below B sharp. That would be an E sharp. Congratulations! You've just successfully constructed perfect fifths above and below various pitches using the key signature method. Hopefully by now you're getting into a rhythm, to borrow a musical term, of understanding how this process works. What once seemed a little scary and complex with thirds should now start to feel more comfortable. I mentioned earlier that you can use the counting half steps method to construct perfect fourths and perfect fifths. Let's see how that works. While this is true, and I'll walk you through the process of how to do it, it's not the method I recommend. There are too many numbers to remember, and it's too easy to miscount. I'll demonstrate. Let's say we're starting on a C, and we're moving up to an F. We know this is a perfect fourth because in the key of C major, we have an F natural. Let's count how many half steps are between these two pitches. Starting on C, 1, 2, 3, 4, 5. 5 may not seem like a lot to some of you, but it's easy to get off track when we're counting this many half steps. What about a perfect fifth? Well, C up to G is a perfect fifth. We know this because in the key of C major we have a G natural. But let's count the half steps. Starting on C again, 1, 2, 3, 4, 5, 6, 7. That's a lot of half steps. So in my opinion, stick with the key signature method once we get to these wider intervals. If you were paying attention, you may have noticed that the interval of a perfect fourth has 5 half steps, and the interval of a perfect fifth has 7 half steps. If you notice that, you may be wondering, why did we skip the one with 6 half steps? Which interval has 6 half steps? Well, I'm going to tell you, but not today. I promise we'll get to this in a future lecture. One more stretch break. It's a good idea, and it's good for your brain. Time to learn some sixths. We can follow the exact same process of using the key signature method, as we did with perfect fourths and perfect fifths, to very successfully construct major sixths, which we can abbreviate with capital M followed by the number 6. We start with our staff, and our circle of fifths for reference. If our first pitch is an E flat and we're writing a major sixth above, we start by putting it on the staff. We can go line, 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 plus 1. That'll give us a C. In the key of E flat major, we have 3 flats: B flat, E flat, and A flat. C is not on that list of flats, so this already is a major sixth above E flat. What if we're doing a major sixth below? We'll count down space, 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 plus 1 more, and that will put us on the B line. If we check our circle of fifths, B major has 5 sharps: F, C, G, D, and A. G is on that list, so we would need a G sharp if we were finding a major sixth above B. However, we're finding a major sixth below G. So, if B to G sharp is a major sixth, B flat to G natural is also a major sixth. We took both pitches and brought them down by a chromatic half step. And if you remember what we learned in Lecture 7 about a minor interval being 1 half step narrower than its major interval, we can change each of these intervals to make them minor. So we determined a C is a major sixth above E flat. However, what if we're trying to find instead a minor sixth above E flat? We need to make this interval 1 half step narrower by adjusting the top pitch, which is a C. In order to do this, we need to bring the C 1 half step closer to the E flat. And we can accomplish that by putting a flat in front of the C. A C flat is a minor sixth above E flat. And if we are to make this interval a minor sixth, if we are to adjust the lower pitch to make our interval 1 half step narrower, we will need to raise that lower pitch up a chromatic half step. In order to make that B flat 1 half step closer to the G, we need to make that B flat into a B natural. I purposely didn't spend as much time on sixths today as I did on fourths and fifths. Part of my reasoning for doing it this way is because the process is similar, but I'm sure some of you would like a little more practice. We will do some review at the beginning of our next lecture. However, for a quick recap of what we learned today, we've learned how to construct perfect fourths, perfect fifths, major sixths, and minor sixths. Take some time to practice these with our online tools. But we'll also take a little time to review sixths at the beginning of Lecture 9.